This video, I'm going to simulate Opamp comparator with zero and non-zero reference and obtain hysteresis curve. Actually, the Opamp in the diagram shown, it is for Smith trigger, where it compares two reference voltage UTP and LTP. First, let us do the Opamp comparator. So I was explaining here. So this is actually a Smith trigger. Okay. And basically, Opamp is a comparator which compares input present in inverting input terminal and non-inverting input terminal. So Opamp has two inputs, one minus and another is plus. Minus one is inverting input terminal, and plus is non-inverting. And in this Smith trigger, this sinusoidal input, what you had given here, that sinusoidal voltage is compared with reference voltage here. We have to calculate when the output is plus V naught set, we got UTP, and the output is minus V naught set, call it as LTP, lower threshold voltage and upper threshold voltage. So according to that, output will change. Output of comparator will be always plus V sat or minus V sat. So first, I'm going to explain how Opamp comparator with zero reference we are going to do. Okay. Here one more circuit is there. Okay. This is you have to take only one comparator. Input is given to the plus terminal, and another voltage, another terminal is simply grounded. So now we are comparing input V in voltage with zero reference. Whenever input voltage is greater, that means plus terminal voltage is greater, you are going to get plus V naught sat, saturation voltage. That will be equal to 90% of what VCC are given. And output is negative. You are going to get minus V sat when the input is less than 0 volts. So here input is compared with ground. So that's why it's called as zero crossing detector. Whenever input crosses that zero value, you're going to get. Now let us simulate this non-inverting zero crossing detector using Opamp. So for this, I'll start with file new. I'm selecting blank. I'll place one Opamp sinusoidal input. Place component. Opamp I have to select. So you can select Opamp. Search in the, it's not in the basic, I think. Go to analog. In the analog, I think analog virtual is there. PAMP is there here. And even comparator is also directly available. Different comparators are there. I think we can take any one of these. So let me take Opamp only. I'll take this Opamp. Okay. I'll place here. Okay. Opamp. Inverting input terminal, non-inverting input terminal. Opamp is number 6, 4 and 7. Okay. After that, here the diagram is plus terminal, we have to give input voltage. So I'll place one component input voltage. So I will select sources. In the sources, signal voltage sources, I'll select AC voltage source. I'll place here, and I want one ground. I'll place here. Okay. Next, another ground, because second input reference voltage is 0, and one more I'll place for output here this side. Opamp has two input, and we are checking whether input voltage, this is the input voltage, Okay, I can change the label. I'm clicking on V1. I will change the label as input voltage V in. Okay, input voltage V in. Now I will connect one RL here. Place component. I will place one resistor. The basic resistor is there. This is we can consider as a load resistance. Close. And we have to connect to check the output. I'm connecting on CRO oscilloscope. Two channel oscilloscope I am placing here. Output I'll connect here. This is across RL we are finding output. And input also I want to see. Yeah. And we need to give power supply. Okay. I think 4 is 13 or minus 15. Let to check it. So place component power source plus we can connect to VDD, VCC and VDD. Okay. VCC and V rotate here. Okay, this one you can change it to 10 volts or 12 volts. Supply voltage is 12 volts. Opamp use dual power supply, two types of power supply, plus and minus. We are giving this. So let me check whether which is connected to positive. You have to check properly before giving. I think 4 plus for 7 it is positive. Okay. For 4 it is negative. 7 positive. Yeah, 7 is positive. Now connection is over. So we are doing zero crossing detector. Whenever input crosses 0, so I'm changing the peak voltage to some 5 volts value. 5 volts peak. Okay, when the input crosses 0, then output should change. So that is the meaning of zero detector. Okay, so now click this run button. You will get like this. So you have to zoom it. You have to expand time base axis. So it is 10 division, 10 millisecond per division. So I am reducing this. Now it is 5 millisecond per division. Reduce this 2 millisecond, 1 millisecond per division. And now you can click single. Okay, I will increase this one a little bit. Now I will explain the output. You can see input. This is the zero level, right? This is the zero level. This is the sinusoidal is the input voltage. So I will change better. I will change color of the input signal. I'm selecting this channel B line. Right click, color segment. I will change the input to blue color, and I will change the output to green color. Okay, I changed the color to green and blue. Now if I run that, you can see blue color is the input. Input is sinusoidal. Okay, I will ground channel B. Channel A is output now. This is channel A. This is channel B. I am grounding this. So now you can see only blue color which is connected to the B channel. It is the input sinusoidal waveform. it is 5 volts. One box multiplied by 5 because we are given amplitude as 5. So its input is this. So zero crossing detector means whenever your input crosses zero level, this is horizontal in middle one. Whenever input crosses that, output should change from one state to one value to another value. So see the here for this portion for positive off cycle, pin number 3 is this is a comparator. Opamp is a comparator which compares this pin number 3 voltage with pin number 2. If pin number 3 voltage is greater, output is plus V naught sat. If the negative terminal voltage is more, output is minus V sat. So for this portion, input is greater than 0, so output is plus V naught sat you should get here. Now let us see output. You are getting this. Okay. For input greater than 0, output is coming plus V sat. Now input is automatically goes negative also. Okay, because it is a sinusoidal, it is going in this portion input goes negative. So for this portion actually 0 is greater than negative voltage. Pin number 3 we have negative minus 5. Okay, any value between 0 to minus 5, but pin number 2 is 0, but 0 is greater than negative voltage, so that time output is changes to comparator output changes to minus V naught set. Again it crosses 0 level and it goes to positive off cycle immediately. Plus terminal voltage is great, so output becomes positive V naught. So output of comparator is always plus V sat or minus V sat. In this case, we are given reference voltage as 0. We are given reference voltage as 0. So therefore, whenever it crosses the 0 value, see here first it is crossing 0 value, it is changing from plus V naught to minus V sat. Again, input is changing from minus to plus, here it is crossing 0. So output is changing from minus V naught to plus V naught sat. Again, input changes from it is crossing 0. Again here also it is changing. Again here also it is crossing. So whenever input crosses 0, it detects and output changes from plus V to minus V naught set, minus V naught set to plus V naught set. So this is called as zero crossing detector and non-inverting. Okay, for positive off cycle, you'll get positive, you'll get plus V naught set, and here if I reverse this, you will get opposite. Okay, that is inverting zero crossing detector. Okay, so this output is over. Similarly, we can also do. Okay, we can also do this. Negative will ground. Negative we will give input and plus we are going to ground. So for that you can change here only. Just copy this full circuit. Control C for copy and Control V for paste. Now this I am deleting. I will invert vertically, flip vertically. Solar 4 minus 12 volts. Again this also rotate. 7 plus 12 volts. This minus 12 volts for 4. Number 6 is output. Input now given to the minus terminal, and plus terminal is grounded now. Now you're going to get opposite output. You can check it out. Run this. This is the output for this one. Now I'm going to oscilloscope number 2. Here, one more input I have to connect here. Click escape. Both the grounds are connected to common ground. Now if I run this, see here, see the difference between this and this. In the first circuit, input voltage given to the plus terminal, negative is grounded. In this one, I flipped vertically. This Opamp symbol, I right click and flip it vertically 90 degree vertically. So it becomes minus, and this the entire diagram it's flipped here. So minus terminal 2 is here, so it's connected here. 3 is grounded. Now when the input is plus terminal is now grounded. Now input is whenever input is greater, that times negative terminal voltage is more. Output is minus Vsat. See for this portion output is minus Vsat. For negative portion after inversion it is coming positive. Okay, so this is about zero crossing detector. This is non-inverting. This is inverting. Now with reference we have to do. So for with reference, okay, I'll show you here only. Please observe. This is actually we are measuring with respect to uh, 0. It is crossing 0 now. Instead of 0, I want some voltage value. For example, whenever input crosses plus 1 volt. Okay. So stop here. Place component. Now you have to select DC power, and I want to place here. Okay. Now earlier what it was detecting 0 whenever 0 is crosses. Now instead of 0, let us detect some voltage value. I'll give reference voltage as 2 volts. So whenever input crosses 2, that time only output should change from one state to another state. So let us run this. Observe here. Now it is that waveform was here. Now it is changed to here. This level is 2. This level is 2. Whenever input crosses 2, output changes from one to another. Again, input changing at 2 plus 2 only. So whenever input changes at 2, again output will change. So this is that level plus this also. Whenever input crosses plus 2, okay, output will change. This is 2 volts, 2 volts, 2 volts, 2 volts. Output is changing from one state to another state. Okay. Similarly, if you want to have two reference voltage, okay, then you have to go for Smith trigger. That I will explain later. Here also, we can also change this value to minus 2 volts, so that whenever input crosses minus 2 volts, output will change. So this is actually called as some reference voltage. Whenever it crosses, we can have that voltage. So here, first we did what? Opamp comparator with zero crossing detector we did. Second one is non-zero reference. Non-zero means we have to give, instead of ground, we have to give some voltage. So here we use Smith trigger. Okay. And how to find a hysteresis curve, no? That I will tell you now. So to find a hysteresis curve, you have to press A bar B. You'll get like this. Okay. You change the frequency to 50 hertz or 1 hertz, so that you will get like this. Harmonics will not come there. You'll get like this. This is the hysteresis curve, and this value is 2 volts because it is 2. For 0 reference, this will be exactly here. Okay, I'll show you. I'll stop this. Instead of 2 volts plus 2 volts, I'll give 0. Okay, now exactly you can see it will come in the center. Again, it is coming here. I can give negative voltages also. Instead of positive voltage, I'll give minus 2 volts. If I give minus 2 volts, this hysteresis curve will shift left side. If I give positive voltage, it will shift right side. Whenever input crosses minus 2 volts, output will change. So it is coming left side. This is color. This is coming single line because I used the frequency less than 100 you put, you will get like this. If you give 1K and all, many harmonics type, many lines it will come. Okay, so this is hysteresis curve. So in the next video, I will explain how to perform Smith trigger, where we can compare on upper threshold voltage and lower threshold voltage. Okay, please watch next video also. Thank you.